Okay, so
paper died.
we continue with question 4 now. Question 4 says, using the definition of the derivative from first principle, calculate the derivatives of the following functions, then find the values of the derivatives as specified. So we have the first function here, function A. So we want to find the derivative f prime. By first principle, the definition says you get the limit as h goes to 0 of the function fx plus h, then subtract fx, then divide h. That means the limit as h goes to 0, where there is x in the function f, you start by substituting x plus h, have it squared in brackets, minus the original function 4 minus x squared. And then everything divided by h. So then when you do the expansion, we have the limit as h goes to 0. Then now we expand. So we have 4 minus x squared plus 2xh plus h squared in brackets minus, okay, that's what, okay, so where was I now? So I was saying, then you also expand the other one. So we have 4 minus x squared just over h. That means the limit as h goes to 0, so that will be 4 minus x squared minus 2xh minus h squared minus 4 plus x squared. We divide by h. So we get, so this part and that part cancels. This part and that part cancels. So whatever will be remaining up there will always have a touch of h. Okay, so the limit as h goes to 0 now, you factor out h, you get minus 2x minus h, and then divide by h. So you see, this part and this part will cancel. So the reason why we're doing all this, we were avoiding to have a 0 in the denominator. That's why we had to evaluate until the h that was giving us a 0 down there leaves that place. So once the h is no longer in the denominator there, we can now take 0 while there's h. So we remain with minus 2x minus 0. So minus 2x becomes our derivative. Then you extend, you also find f prime of -3. This means you get, where there's x, you put -3, so you have 6. You also get f prime of 0, again meaning where there's x in the same derivative, you put 0, so you have 0. Get f prime of 1, so you have -2 by 1, which is -2. Like that. So what is key is this definition here, this one. It's very important. Okay. So these questions like B, they move together with A. C, we're just from doing x squared. So nothing changes if it goes down. You just do the replacements there. This one here too, nothing much. And E also nothing much. So maybe we'll deal with, between E and F, we can do one. Which one do you think is good for discussion?
Excuse me, sir.
Yes.
F.
I wanted to ask on question C.
Mm-hmm.
So is it okay if you write the equation by saying x to the power 2 negative 1?
Well, not necessarily.
Or
Just
you just
write it direct. Just write it the way it is. So we go to F. So when it's X, we put X plus H. And then bring the 1 minus 2x plus 1. And then divide by H. That means the limit as H goes to 0. So now you see, we want H to come out of the numerator there, so it can cancel the one that is down. But the H that is in the numerator is in the root. So we'll have to rationalize the numerator. So we rationalize. We multiply by the root of 2x plus 2h plus 1 plus 2x plus 1. And down by the same. 2x plus 2h plus 1 in the root plus 2x plus 1. So now you have this equal to the limit as h goes to 0. So that guy by that guy, you just get the inside, which is 2x plus 2h plus 1 minus this guy by that guy. You get minus 2x minus 1 and divide by h times this product here.
Sir,
Hello.
when you are doing it, when you are multiplying the numerator, you want to multiply the first one with the first one and the second one with the second one. If you don't show for the other two, like, I don't know if you are getting me.
Yeah, I'm getting
You
you.
don't you lose a mark.
No, you don't.
Yes, but you know what oh, okay. Right.
Because you've been doing that thing in topic 1. So if they just say rationalize, you can show how those are crossing out. But then it's not just about rationalizing, then you can go the shortcut way. So this and that will go, this and that will go. And then that h and this h will cancel. So now I'll remain with 2 over, I put a 0 here, then I'll have 2 of them. So I'll have the root of 2x plus 1 plus the root of 2x plus 1, which is equal to 2 over 2x plus 1, which is 1 over the root of 2x plus 1. You see? But because they are the same down there, we can add them. Okay? Then you can start substituting now those numbers. Put 0, put 1. Yeah, then you can do anything that you want to do. Yeah? So forget about this f prime is supposed to be h prime.
So excuse me, sir.
Yeah.
You have cancelled there. You have cancelled 2 and also 2 from the numerator and also 2 from the denominator. So if it was like let's say 2 on top, then 2x on the denominator, do you also cancel like 2 to remain with 1 over x?
I have not cancelled in the denominator the 2 and in the numerator the 2. No. I have subtracted in the numerator. 2x minus 2x is 0. 1 minus 1 is 0. So those have vanished. So now we remain with 2x, and with 2h over h times those things in the brackets. That's why we divided this h into this h. If there was a plus something here, I could not divide. This can't be done if there's a plus something. So we could do that because everything else got cancelled. So then now I could divide that h into this h.
Good man. Excuse me, sir. So when replacing those values, you replace them in the final answer or just
You place in the final one.
okay.
Okay. We come and drink water here. In the following, find the indicated derivatives. Use any method that you know. Okay? If you know any method, use it. But even if you know first principle, you don't use first principle in search. You just go straight and do the derivative. So here I'm going to use power rule. Power rule says you differentiate. To differentiate, you drop down the power, multiply by the coefficient, and go back to the power and subtract a 1. So like 5a, to find dy dx, you go to the power 3 multiplied by 2, then you have x, 3 minus 1. That would be 3 times 2, 6, x squared. So that's power rule. If you find the function is r is equal to that, then they have said find dr ds, meaning now the variable is s and the r is a function. So it will be dr ds is equal to 3s squared over 2. The derivative for any constant number is always 0. So no big issue here. So we're saying to differentiate this, dr ds is going to be 3s squared over 2 plus 0. So power rule is not that much complicated. Just drop the coefficient, just drop the power, subtract the 1 from it. That's enough. Okay, now let's go to C. C, we use quotient rule. Remember, when I say quotient rule, I'm mentioning them just because those are things that we started by. Remember, we discussed this calculus before this spreadsheet came out. And we had the examples from the spreadsheet for 1100. And so we differentiated this like the t over 2t plus 1. That's just a fraction. So we talked about quotient rule. We talked about chain rule. We talked about power rule, product rule. So here you use quotient rule on C. You use power rule on D. You use chain rule on E. You use chain rule on F. Unless there's an exception here, maybe we can answer, but I feel these are things that we did.
Sir,
Hello.
on E, you said we're using channel, right?
Yes.
So how are we going to drop this numerator now?
Drop. That is like P is equal to Q plus 1 to the power negative half, right?
Yes.
So,
Oh, yes. I got confused.
okay, good.
Thank
So you drop the power, then Q plus 1 minus 1 from the power, then differentiate Q plus 1, you get 1. And then you can write things now, take part to what belongs down, take it down. You see? So let's spend our time on 6 maybe. Differentiate the following functions and find the slope of the tangent line at the given value of the independent variable. So to differentiate is to find the derivative. To find the slope is to substitute the number x in the derivative. Just like we are doing using first principle, yeah? So like 6a f is equal to x plus 9x negative 1. When you differentiate it, you have 1 minus 9x minus 2. That is 1 minus 9 over x squared. Then in the derivative, you substitute minus 3 where there's x. So you have 1 minus 9 over minus 3 squared. That would be 1 minus 9 over 9, which is 0. So you have 1 minus 1, which is 0. So the slope is a gradient. So it is 0. And you know, when the slope is 0, okay, in answering the question of the slope, we have found the slope is 0. But it also means that that tangent line is horizontal. It's a line like that. It's the one whose slope is 0. So all we'll be doing in B, in C, and in D is just to differentiate the function. In our derivative, you substitute 2, you substitute negative 1, you substitute negative 2, then you're finding the slope. You're finding the gradient. Is that too much for you guys? Okay, I know what you mean, you guys, when you're quite, you're always like, let's move on. 7. Differentiate the following functions and then find an equation of the tangent line at the indicated point. So now this time around, it's not about the slope just. It's about the equation of a tangent line. It's about the equation of the tangent line. So the equation of the tangent line is y equal to mx plus c, or y minus y1 is equal to mx minus x1. That easy. No much complications. So now, let's pick a function. We pick a function. Which one? The first one. So the function is f of x is equal to 8 x minus 2 power minus half. So we find the derivative. F prime of x is going to be 8 multiplied by negative half x minus 2. Then negative half minus 1, it will be minus 3 over 2. And then you multiply by the derivative of the inside, which is 1. So this is just going to be negative 4 x minus 2 to the power minus 3 over 2. This is the derivative. Now we need to find m. So m, we substitute the given point in the derivative. So where there is x, we put 6. So we have minus 4, and then 6. 6 minus 2 is 4. 6 minus 2 to the power minus 3 over 2. So this is minus 4 over. That's the square root of 4 to the power 3. Yes? So that's minus 4 over 2 power 3, which is minus 1 over 2. So that's the gradient. So when I come here, I'll say y minus y1 is 4 there, is equal to m, which is minus half. X minus x1 is 6 on the same point. And this is the equation. Okay, so you guys would do the same thing on G, and then find the values of the following derivatives. So here is just to differentiate. After you differentiate, where there is that variable, you put a 1, just like that. So let's demonstrate on 1. Let's do this one. So we want to find dw z, meaning we differentiate w with respect to z. So we're differentiating z. The derivative of z is 1. The other one is like z to the power half. So its derivative is half. z to the power minus half. So we have 1 plus 1 over 2, the root of z. And then where there is z, we substitute 4. So it will be like 1 plus 1 over 2 by 2, because root 4 is 2. So we get 1 plus 1 over 4, which is 5 over 4. You see? So it's just about the art of differentiating. Then later on you substitute something. Not complicated.
So
But sir,
can you also do B?
sir,
Hello.
May I have a question? Why is the one? Isn't that we're using the equation for W is equals to Z plus the root of Z?
That's why I'm differentiating.
Huh?
What's the derivative of x?
It's 1.
What's the derivative of z?
It's 1.
So which one is confusing you now?
Okay, why are we raising the Z again to negative half?
What do you mean to negative half? This was z to the power half. When you differentiate, you subtract the 1. What is half minus 1? Because you guys, we agreed that whenever you see a root, you write this as that. Is it? So to differentiate, you get 1 plus half z half minus 1. But half minus 1 is negative half.
So can you please do B?
B. What's the derivative of 1? So b y is equal to 1 minus x power minus 1. So dy dx, derivative of 1 is 0. Then we drop 1, right, like this. So we have minus, when we drop the minus 1, x minus 1 minus 1. So that would be plus 1 x minus 2. That would be 1 over x squared. Good. Then where there is x, substitute x is equal to 3. So you have 1 over root 3 squared, which is 1 over 3. You see? It's just about the derivatives. Just about the derivatives. Okay? Question 9. For each of the following functions given below, answer the following questions. Find the derivative of the given function. And you can find derivatives for all these functions here, is it? We're just from doing for minus 1 over x. You can do for x4 over x that. You can do for minus x that. You can do for that. For what values of x, if any, is y prime positive, 0, or negative? So let's check. We have this, the first one. Let's get dy dx. So dy dx, let's use y prime. Since they've said we should use y prime. So y prime is equal to minus 2x. For what values of x is this derivative positive? So it will be positive. With positive, we mean greater than 0, is it? For all the values of x that are less than 0. So you say for x less than 0, y prime will be greater than 0. Will be positive. Then, where is it 0? It is 0 for x equal to 0, y prime is 0. So just like equating to 0, make it greater than 0. And then the other one, you solve for minus 2x less than 0. So it is for all x greater than 0. Y prime will be less than 0. Less than 0, it means it's negative. And then, over what intervals of x values, if any, does the function y increases as x increases or decrease as x increases? So here, you want to appreciate what it means to have the derivative positive or negative. So if the derivative is positive, then the function is increasing. So as x decreases, the function is increasing because its derivative is positive. Then, as x increases, the function is decreasing because its derivative is less than 0. So it is decreasing as x increases. So for what value, for over what intervals? Here from 0 to infinity, here from negative infinity to 0. And you explain what happens. It's increasing as x decreases. Here it's decreasing as x increases. You understand?
Can you repeat on the increasing and decreasing?
So you say f is increasing if its derivative is positive. Decreasing if the derivative is negative. So here, because the derivative is positive, we are saying f is increasing. But what makes a derivative positive? The values of x less than 0. Here, what makes a derivative negative? The values of x bigger than 0. When you look at
Okay,
this,
thank you.
does the curve have any horizontal tangents? If so, where? Give reasons for answer. So you just differentiate this. You say, okay, what's y prime? Y prime is 2 half x to the power minus half. That is 1 over root x. Can this derivative be 0 at any point? No, because the variable x is appearing in the denominator. And it's the only thing in the root there. So this derivative cannot be 0. So we don't have any horizontal tangents here. Reasons, because the derivative is never equal to 0 for any value of x. Remember I mentioned up there that if you found the derivative to be 0, it means that the gradient of that line is horizontal. So now here you won't have any horizontal because the gradient is never getting to 0 for any value of x that you put there. Okay, so what about this one? Does the parabola this have a tangent line whose slope is -1? You check. You check, you differentiate it. So if we differentiate y prime, we'll get 4x minus 13. Do you think this can be equal to -1 at any point? Let's see. We'll have 4x is equal to 12. So when x is equal to 3, we have the slope -1, yes. If so, find the equation of the line and the point of tangency. So the point of tangency, since x is 3, you get 3 and substitute in the original y. So you have 2, 3 squared minus 4 minus 13, 3 plus 5. That is 18 minus 39 plus 5. So 18 minus 39, that's 1 here minus 2 plus 5. That is what? Minus 16. Minus 16. So the point of tangency is 3 comma minus 16. Now the tangent line, remember the gradient is already found. So we're just saying y minus y1, which is minus 16, is equal to m, which is -1, x minus 3. So you get y plus 16 is equal to minus x plus 3. So you could put these numbers together if you want. Y plus x is equal to minus 13. Like that. So the question was, does it have a slope which is -1? How do I know? I differentiate and get the first derivative. I know the first derivative gives me the slope. So I equate it to the given slope. If I find a reasonable x, then it does have the slope -1, add that to x. For me to find the point of tangency, I substitute the x in the original function to find the y corresponding value. So we have found -16. So now we now have a full point. A full point together with the gradient can be used to find the equivalent of the tangent line. So you answer 12. Does it have the tangent line the curve that close the x-axis at x is equal to -1? If so, find the equation. So think about it and get it correct as you enjoy the night and the weekend.
Thank you, sir.
When are you writing the test?
Don't you say that the lecturer is the coordinator?
Hey, no, like
forgot.
I'm not the test. I'm not asking about the test for us, like the test. Yes, I know it's on the 15th. Like I mean for this group, I don't know if it's a test or a what.
No, it's